All right, tangents to circles is the topic right now, and when we're looking at this, first we're going to get a little mathy and say that if a line is tangent to a circle, then it's perpendicular to the radius drawn to the point of tangency. So if line L is tangent to circle Q at P, then L is perpendicular to QP. All right, let's look at one more, and then we'll actually practice it so it makes more sense. In a plane, if a line is perpendicular to a radius of a circle and its endpoint on the circle, then the line is tangent to the circle. So, if line L is perpendicular to QP at P, then L is tangent to circle Q. That's a lot of math. Let's go into that a little bit. All right, verifying a tangent to a circle. This is where you use the converse of the Pythagorean theorem. Now, the converse of the Pythagorean theorem is when I give you all the values and you have to see if it's true. So I have a squared plus b squared equals c squared. Now, when I look at this, what I'm going to do is I'm going to say my longest side is c. That's the hypotenuse. I have a and I have b. So 11 squared plus 60 squared equals 61 squared. 11 squared is 121 plus 60 squared is 3,600, and 61 squared is 3,721. Now what we have to do is just make sure that the left side equals the right side, so 121 plus 3,600 is 3,721, and that is in fact equal to 3,721. So that's how we prove that line EF is perpendicular to DE. So we could also say that EF is tangent to circle D. Let's look. So the next one is finding the radius. Now this looks more difficult than it is, but don't worry. The first thing we have to do though is look and say, okay, this is where my right angle would be. It would be between AB and BC, which means that AC is R plus 8. And that's going to be a little bit of a tough part, but that's okay. So that's also side C, and I'm going to mark that with a C. So I have R squared plus 16 squared equals R plus 8 squared. R squared stays where it is because that's what we're looking for. 16 squared is 256. Now to do R plus 8 squared, what I'm going to do is I'm going to set up my lattice. This is what I did back in Algebra 1 if you don't remember. I have R plus 8 on the top and I have R plus 8 on the side. R times R is R squared. R times 8 is 8R. 8 times R is 8R. And 8 times 8 is 64. I'm now going to combine my like terms. My like terms are 8R and 8R. They're diagonally across from each other. So that gives me R squared plus 8R plus 8R is 16R plus 64. So I have R squared plus 256 equals R squared plus 16R plus 64. Okay, this is where what I have to do next is something that I'm really used to doing. I'm just going to solve. So I'm going to start by subtracting R squared from both sides, and it actually cancels. So I have 256 is equal to 16R plus 64. Now I'm just going to cross out those R squared so that you can see that they cancel. Subtract 64 from both sides. 256 minus 64 gives me 192. So 192 equals 16R. Divide 16 from both sides so you get the R alone. So 192 divided by 16 gives me 12. So the length of the radius is 12. Let's do a few more examples. Okay, so this one, what we really have to remember with this is that these are congruent if they meet at the same outer point. So RS is congruent to TS if they are both tangent to the circle, and meet at an intersection point, which is point S. All right, what does that mean? Let's do an example. All right, so AB is tangent to circle C at B. That means that B is my point of tangency, and AD is tangent to C at D, so D is also my point of tangency. Now this is where we get good. We mark that they're both congruent. So I'm going to say that DA is equal to BA. So DA is x squared plus 2, and BA is 11. Now I just solve. So subtract 2 from both sides. So x squared minus 9. Now because I have a square, I have to take the square root. And I know a number multiplied by itself would give me 9 is 3. So x is equal to 3. The next example, I'm going to do the same thing. So I'm going to say that BA is equal to DA. And then I'm going to put my values in. So 5x squared plus 9 equals 14. And from there, I solve. Subtract 9 from both sides. So I'm left with 5x squared equals 5. Divide 5 from both sides, so my coefficient cancels and I'm left with x squared. 5 divided by 5 is 1. Take the square root of both sides, and the square root of 1 is 1, so x is equal to 1. One last example. This one's a little bit more difficult. So I'm still going to say that DA is equal to BA. So 2x plus 5 equals 3x squared plus 2x minus 7. Now what I have to do is I have to get everything on the same side. So I'm going to subtract 2x from both sides. So I have 5 equals 3x squared minus 7. I'm going to subtract 5 now from both sides. It's okay to have it equal to 0. So 0 equals 3x squared minus negative 7 minus 5 is negative 12. Okay, what I can do now is I can factor out a 3. So I'm going to say 0 equals, what do 3x squared and negative 12 have in common? They have a 3. So I'm going to say x squared minus 12. I'm sorry, that should have been a 4. Because 12 divided by 3 is 4. Alright, what I'm going to do now is I'm going to solve. So I'm going to say 3 equals 0. We know that's not true. So 3 is not a value. So my other binomial is going to say x squared minus 4 equals 0. I add 4 to both sides. So x squared equals 4. Take the square root of both sides. So x equals 2 is my real solution. And that's what you should know about tangents.